Hi everyone, this is Mrs. J, and today we're going to learn how to graph quadratics from Intercept form. But first, please pause video and try this quick warm-up. All right, go ahead and check your work real quick. So this is how we graph from standard form. So we use this formula to find the x value of a vertex, plug it in to find the y value. So our vertex at -3, 4. And then from here, I use that vertical growth pattern we learned about, or just simply plug in x values to the left and right of your vertex for more exact coordinates. We have a maximum value at y equals 4. Our axis of symmetry is the equation x equals -3. And then you can check your domain and range below. So today we're going to learn another form of quadratics that we will be encountering and graphing from, and this is called intercept form. So intercept form looks like this. F of x equals a times x minus p times x minus q, where p and q are the x-intercepts. So notice this says negative p and this is positive p. This is negative q and this is positive q. So what you see in your equation and what your intercepts are should always be opposites. So you can see that essentially our equation is factored. So we call this intercept form because you can actually see the x-intercepts. So if you know where your x-intercepts are, the x value of a vertex is always going to be somewhere halfway in between those two intercepts. The way you find a value halfway in between 2 points is you add up those values and divide by 2. So that will give you the x value of your vertex, and then you can simply plug that in to find the y value. And then from here, I'm still going to be graphing with that vertical growth pattern 1, 3, 5, adjusted for any vertical stretch or shrink. But again, you could always plug in points to the right or left of your vertex to get more coordinates. All right, let's try this first one together. So here I see that we are in intercept form. So for my x-intercepts, I see that since this is x plus 3, I actually have an x-intercept at -3 and then +1. So -3 and +1. Now to find the x value of the vertex, remember it's going to be halfway between these two numbers. So we simply add up those two numbers and divide by 2. So we should get -1. And you can kind of look, we can see -1 is exactly halfway between. So that's the x value of our vertex. So let's plug that in to find the y value. So -2 times -1 plus 3 times -1 minus 1. I'm just plugging it into our function here. So -2 times +2 times -2. So f of -1 is +8. So my vertex is -1, 8. And then if I want more exact coordinates, again, I could make a t-chart, or I could follow that vertical growth pattern. I see that my a value is -2. So my vertical growth pattern is going to be -2, -6, -10. So I can go down 2 over 1, down 6 over 1 brings me here. I could go down 10 over 1, and then I can just reflect those coordinates over the axis of symmetry. Okay, and then for practice again, we're going to name our max or min. This one is downward facing, so I have a high point, which is a maximum, and that will always occur at the y value of the vertex. My axis of symmetry is always the vertical line that goes through the x value of the vertex. Our domain should always be all real numbers, and our range in this case is -infinity to +8. All right, let's try another one together. So again, I can see that my x-intercepts are going to be +4, -2. Remember, they're opposites of what we see in the factors. So +4 and -2. So let's find the x value of our vertex by finding that halfway point. We add them up and we divide by 2, so our halfway point is x equals 1. But again, that's just the x value of the vertex. We need to plug it in to find the y value. So negative 1/3 times 1 minus 4 times 1 plus 2. So negative 1/3 times negative 3 times 3 gives us positive 3. So our vertex should be at 1, 3. Then I could follow my vertical growth pattern again. So I'd do negative 1/3 times 1, 3, 5. So I get negative 1/3, negative 3/3, which is 1, negative 5/3. So some of these points I may need to estimate. So down 1/3 over 1, down 5/3 over, or down 1 over 1. So I'll estimate that one as well. And then if I go down 5/3 over 1, I get my x-intercept. So that means that we graphed correctly. Or again, alternatively, I could always plug in x and y x values to the left and right of my vertex to get more exact coordinates. Here again, we have a maximum because of the downward facing parabola at y equals 3. Our axis of symmetry is x equals 1. Our domain is all real numbers, and our range is negative infinity to 3. All right, here I have one for you to try on your own, so please pause the video and give it a shot. All right, go ahead and check your work here. We have x-intercepts at negative 1 and negative 5. So the x5 vertex is halfway in between at negative 3. Plug it in to find the y value of 4. So check your work below. Again, I graphed using my vertical growth pattern. Okay, here's the last example. So one more time, pause the video and give it a try. Okay, go ahead and check your work. Here, this one looks a little tricky, but this just means that your factor is just x plus or minus 0. So if you don't see anything added or subtracted to one of your x's, it just means that you have an x-intercept at 0. So 0 and negative 4 are your two x-intercepts. So the x-value vertex is negative 2. The y value should be negative 8. And then go ahead and check your additional information below. All right, that is all for today's video. Thank you so much for watching.